Hello friends, welcome to our Hariharan Express channel. Today I will discuss regarding on different logic gates and its algebraic function and its corresponding truth tables. So whenever you discuss regarding on any kind of hardware components of computer system, then the most important part of this computer system is defined through different logic gates. So logic gates is a very important part of the different block diagram of computer system. So here is what is logic gates. Normally logic gates contains different kind of types or category we can tell, but whenever design or that is use of logic gates that makes various blocks of computer system. So logic gates are block of hardware, and it produces two kind of signals, that is 1 or 0. So different kind of a structure of a logic gates we can discuss today. Various logic gates are there, one after one we will discuss. So whenever we discuss different logic gates, then find out what are the symbols of logic gates, what kind of operations or what its functions, like algebraic functions, and what its truth table. Okay, today various kind of logic gates we will discuss. Now we will start a different category of that is logic gates. Okay, so when we discuss different category of logic gates, first of all we see that what kind of symbols are required to design a logic gates. Okay, so that is important, because when we define logic gates, any kind of logic gates whenever we consider, then we see that what kind of symbols, so what kind of that is a parameter we use by which it identify a particular category of logic gates. Okay, so now we will start our that different category of logic gates and its corresponding symbols. So now we will start with a that is AND gate. Okay, very simple way we define AND gate. So I will that is draw different category of that logic gates, like we can tell one part is okay. So now we see different category of logic gates are we need to define. First we see that is AND gate. How AND gate we design? Very simple way. Normally whenever you go through any kind of logic gates, first of all that graphical representation of logic gates we have to consider. What is the symbolically graphical symbol of any kind of logic gates? Based on that we can define the name of this particular category of logic gates. Okay, so now we start. Here you see the logic gates, if we symbolically define in this way, we can tell as it is a AND logic gate symbol. Okay, and most of the time two inputs, minimum two inputs we just consider for any logic gates. One logic gates one input we can consider, but normally two inputs most of the time we will provide to the logic gates. So let us consider that is A and B, two inputs we will provide to the particular AND logic gates. This symbol, if this symbol is defined or designed, then we can tell as it is a AND symbol, and one output we can get is, let us consider X is one output. Okay, so symbolically if we design in this way, we can tell as this AND logic gates, and two inputs A and B and one output X. In this way we define or a graphical symbol design for AND logic gates. If we go through algebraic function, very simple way, we can define x is equal to, here x is the output. This output depend on a and b. Okay, a and b. This a and b is defined very simple way, that is a dot b. The algebraic function is defined in this way. Okay, x is equal to a dot b. That means two inputs a and b. That the product of that a b generate the output for x. Okay, this is the basic concept. Now we define the truth table. How it is define the truth table? Because depend on the different inputs value, we can get the output. So truth table also defined accordingly. Now we see how truth table is defined based on this particular AND gate. Okay. Now see how it is designed, or how to evaluate the truth table from or for AND gate. Here we see, if we go through different values of a and b, then how it will evaluate and find the output for x. Okay. Here two inputs a and b, two inputs are there. Okay, here two inputs. So two inputs value, normally we consider that inputs value is 0 or 1, either or both. Okay, not at a time, because one value it will receive. So very simple way, we will consider that values 0 or 1 for a and b. Then we see that what is the output value for this AND gate. So x is defined or depend on a and b, the product of a and b. So based on that output we can get it. Now we see a value, let us consider 0, b value 0. So 0 into 0, obviously it is 0. Okay, like this we can define. Here is 0, here is 1. 0 1, obviously 0 into 1 is 0. Okay, the two part is over. Here is 1. If you 1, if it is 0 1 0, it will be 0. Okay, because 1 0, product of 1 0 will be 0. Here if it is 1, it is 1. 1 into 1, that is 1. Okay, so in this way we can create, that is a truth table of AND gate. Like this we define different logic gates with different symbols, and that is algebraic functions and others also. Okay, now we will start differently. So next we define, that is OR gate. So OR gate, very simple way, the symbol is defined in this way, like here just this kind of symbol. Okay, this you see, so round of this of AND gate, but here some that is design in this way, very simple way. Similarly same two inputs will consider, one output also we can consider. Here a and b, two inputs will provide to the OR gate. OR gate symbol is like this. Okay, very carefully if we go through AND gate and OR gate, how it is designed. Same case, here is some algebraic function. If you define x is equal to, actually here what happens when the product of a and b, but here is a plus b. Okay, that is algebraic function defined in this way, x is equal to a plus b. So now we see what is the truth table of this particular OR gate. Okay, now we see how it is defined for a truth table. Similar case we can take 0 0, value is 0 0, that will be 0. Similarly if 0 1, 0 plus 1, the result will be 1. Here is 1 0, 1 plus 0, that is 1. Next similarly 1 1, if we go through 1 1, result will be 1, not a 1 1 is equal to 2, because output always should be either 0 or 1 for the binary values. It will consider if any logic gates will design, so output should be either 0 or 1. I have already told, that is logic gates values just to provide the output as either 0 or 1 based on the what are the values of that. Okay, so here is some whenever we go through this particular algebraic function of or function or gates, so result a truth table design in this way. Okay. So similarly also we define another part, that is a inverter. This is the OR gate. Okay. Next is we can design, that is a inverter. So how to design inverter we will see. Okay, inverter. So inverter is nothing, it is the negative of any data, So let us consider A data will provide A, just a the symbol of inverter is like this. Okay, A data, and it is just a negative of that data. Okay, very simple way. Just we can tell as a complement of data. So this is a very simple. This symbol is defined as a inverter. They are complement of the data, complement of any kind of data. Okay. So now if we go through algebraic function, we can write x is equal to a complement. If we provide a, simple a, x should be a complement. So the truth table of this very simple way we can also define, very simple way. One part a, another part x. Okay. So suppose here is 0, x will be 1. If it is 1, it will be 0. Okay. So very simple way we can define this inverter. Okay. Next remaining I will explain. Okay. So remaining I will tell you that next is buffer. Another that is logic gates, we can tell as a buffer. It is buffer. Okay. So buffer is nothing, only the transfer of data, storage data or transfer of data. Okay, very simple way logic gates. You see, whatever the data we just provide, okay, same data it will transfer, same data, whatever the data provided to the buffer. Okay, buffer symbol is like this. If that is bubble symbol here, then we can tell as a inverter, which I have already discussed that part. Okay, inverter buffer is very simple, data. Inverter, if you go through inverter, then it is just complement of that data, given data. If you go through buffer, then it is just that data transferred to the through this particular buffer or through this gate. This gate symbol is a buffer gate symbol. So here function table is a very simple, x is equal to a. Okay, that data directly we get it. X is the output that depend on a data directly got the output. Okay, x the output x can receive the direct data a. Next simple truth table also we define very simple way. We define that truth table. One is a, another is x. Okay, whatever the data we give a, sorry, it is 0, x will be 0. It is 1, it is 1. Same data we can get it, because that data direct pass, there is no obstacle of that data, direct data we can get it. So this is the buffer. Next we can tell that is a AND gate. Okay, we can see that is a AND gate. Sorry, NAND, not AND. AND is already over. NAND gate. Okay, NAND symbol very simple. First of all, NAND symbol we take it. This NAND symbol we can take it like this, very simple way. NAND gate. Okay, two inputs like this, and one bubble is required to make a negative. NAND means not and, that is NAND. Okay, not and, that is NAND. So very simple, same symbol, but one bubble just put it here, then it will represent as a NAND. So same thing, AX is equal to what happens? So very simple way. Since this, if you go through this one, what you write previously, A dot B, A product of A B. But since it's a NAND, that means a complement of that. Whatever the product of previously NAND, the complement of a NAND means a complement of a AND. So complement of NAND means a complement of a A and B. Like this we defined. Okay. Now the cross table, that is a truth table, also defined in this way. A, B, X, very simple way. Now see, that is a 0, very simple way, 0 0 1 1 0 1 0 1. It is very trick to make that different values of A and B. Okay. So here similarly 0 0, that will be 0 0. If we go through and, that is 0 0 means 0. So 0 0 0 0 complement, 0 complement means it will be 1. But if we go through simple AND gate, that is it will be 0. Okay, because 0 0, that is 0 0 complement. Now since NAND, 0 complement is 1. Similarly 0 1 0, but since it is a complement, 0 complement means it is 1. 0 0 0 1 0, 0 complement is 1. 1 1 1, 1 complement is 0. Okay. So like this we define this NAND gate. Okay. Similarly also we define, that is a NOR gate, just like a negative of a OR. Okay. So negative of a NOR we can write it, that is a NOR gate. 6 NOR gate. Very simple, same thing. OR gate, one bubble we just make it here, bubble. Okay, we can write this OR gate, sorry, NOR gate. In this we can write NOR gate. So same AB, two inputs we provide. This is X. So same thing we will consider, X is equal to, actually NOR gate is addition, A plus B, but it is some complement since it is a NOR gate. Okay. So some complement we will consider. So now see what is the that is truth table, A B X, very simple way. Okay. Now see, so A similarly 0 0 1 1 0 1 0 1. Okay. 0 plus 0, that is 0, but since it is a complement, that will be 1. 0 plus 1, that is 1, plus 1 complement is 0. Similarly 1 plus 0, that is 1, 1 complement is 0, it is 1, 1 plus 1 is 1, 1 complement is 0. Okay. So like this we can define the truth table of NOR gate. Okay. In this way different parts also we can define. So similarly again another part, that is a XOR. We can tell as XOR. XOR some little bit that is a modification of OR gate. You see the symbol is similar like a OR gate here, but two like this we define XOR. Okay. So two input A and B. XOR you see similar kind of OR gate, but another this symbol also we can use to identify this XOR gate. Okay, but here whenever go through algebraic function, we define XOR X is that is A direct sum with B. Previously if we go through OR, that is A plus B, but here is direct sum with B. Otherwise another concept also there we can define, that is A that is a direct sum with B, or another concept also there we can define in this way: X is equal to A complement B plus A B complement, like this. You see once again, A XOR with B means A complement B plus A B complement, like this we define. This is the basic concept of XOR gate. Okay, based on that we also evaluate that values truth table A, B and X. Very simple way I will show you how it is defined. Okay, 1, 2. Very simple way. So now see, here is for example same case 0 0 1 1 0 1 0 1. Okay, now see 0, first A is 0, A0 means it is 1, B0 means 0 0 complement means 1, B0 1 into 0, that is total 0. Similarly A is 0, B complement 1, 0 into 1, okay, that is 0, 0 plus 0. So that means it will be 0, 0 plus 0, that will be 0. Okay, so next another concept, next part 0 1, A complement, if A 0, A complement is 1, okay, and B is 1, 1 into 1 plus A is 0, A is 0 plus B complement is 1 complement, 1 complement is 0, 0 into 0. So this part will be 0, this part will be 1. So 1 plus 0, that is 1. Okay, once again A is 0, A0, A complement is 1, it is 1, and B is 1, so into 1, 1 into 1 plus A0, that is 0, B is 1, 1 complement is 0, 0 into 0. So 0 into 0 is 0, 1 into 1 is 1. So 1 plus 1, 1 plus 0, 1 plus 0 means 1. Okay, this is the basic concept. Another similarly, next case A is equal to 1. So A is equal to 1. A is equal to 1, but A complement is 0. Okay, that is 0 dot. B is 0, B is 0 plus A is 1, and B complement, B is 0, 0 complement is 1, 1 into 1. So it is 0 plus 1, that is 1. So it is 1. Okay, next 1, last case A complement, A is 1, 1 complement is 0, so this is 0, B is 1, 0 into 1 plus A is 1, B complement is 0, is 0, this is 0, this is 0, so total is 0, so it is 0. Okay, so you see whenever you go through XOR gate, we observed here where both are, there is same sign or same value 0 0 or 1 1, result will be 0. If same value, result will be 0. If opposite value 0 1 or 1 0, result will be 1. So very carefully whenever you go through analysis of XOR gate. Okay, very simple way. 0, if same values, that result will be 0. If different values, that is 1. So in this way we can define XOR values. Okay. Similarly, we also define another XNOR. Okay, I will define XNOR value. Okay. Now see the another negative gate, that is a XNOR. Okay, XOR XNOR. Same concept, we just but here is one bubble. Okay, one bubble is here. So two values you input A B, here is will be X. Okay, here will be X. The bubble is here also. So now you see how to define this XNOR function. What happens, X is equal to A, here is defined in this way, XNOR symbol is there. Okay, if we any other way we define like that is A complement B complement plus AB, A complement B complement plus AB, that is X. In this way we define. Okay, and another is that is a truth table also defined accordingly. Very simple way, A, B and X, A, B, X. In this way we define. Very simple way we define. So now we see same values 0, 0, 1, 1, 0, 1, 0, 1. Okay, 0, 0, like this you can take the values. You see now test it. 0, both are 0, 0 complement 1, 0 complement 1, 1 into 1, that is 1. But here is a 0 into 0, that is 0, 1 plus 0, that is 1. Okay, that is 1. Here is 0, that is 1. The complement is 1, 1 complement is 0, so this part is 0. If this one, that will be 0. Okay, because A product B, A dot B means 0 into 1 0, B complement it is 0 complement is 1, B complement is 0, both are 0. Okay, so product of that is 0, so 0 this part 0, this part is also 0. If we go through the reverse, similarly A complement is 0, B complement is 1, both is 0, this part will be 0, so another part also 0, so this part will be 0. If it is 1 1, 1 complement B complement, 1 will 0 into 0. Okay, this 1 complement is 0, B complement is 0, both are 0. But here AB 1 1 means 1, 1 into 1. So 1, 0 plus 1, that is 1. Okay, you see, if we go through that is XOR gate, the value is different. You see, the value is different. That is, if same values we provide, then value is 0. Different values provide, then value is 1. But reverse case of that, you see, same value, then it will be 1. You see 0 0 it is 1, 1 1 is 1, but different values, that is 0. Okay, this is the difference between that is XOR and XNOR. So this is the basic concept I just defined here. Okay, similarly other part also there I will also explain. Okay, so now just some application of different gates or implementing different gates using NAND gate. Okay, so how to implement all gates or different gates using NAND gate, based on that we will consider. Okay, so now we see another gate also we can consider, like a NOT gate. Okay, NOT gate we define, that is we can tell as a NOT gate A, for example, NOT gate A. How to define or how to design? Since it is using NAND gate, so NAND gate first of all we design very simple way. NAND gate we design. This is the NAND gate. Okay, this is the NAND gate. But you see, whenever go through a single gate A using NAND gate, we just draw these two gate in this manner. You see, very simple way. Age data as a 2 input here, it is a using NAND gate. Okay. So result, how to get the result? Result means you see A, again one part A you go to here, another A part also go to here. Okay. So both are, that is consider as A into A, because it is NAND gate, A into A, but here is what happens, NAND gate complement. So now we see what is the result. A into A means A, that means A complement. Okay, that means A complement. Like this we can define different, we can design different logic gates using NAND gate. So NAND gate we use, but result is designed in this way. Result we can define in this way. Okay, that we can tell as it is a not gate A. Okay. Similarly, another gate, AND gate. Here also use AND gate. How? So AND gate, if we go through AND gate, here is two values we can consider. Okay. Now, but using NAND gate also we can use, very simple. And or another bubble is there. NAND gate, two input we will provide. Here is A and B, two input we provide. But since we define this NAND gate, you see these values again define two ways. Okay, again define two ways. You see how it is designed. Okay, how it is designed. So now we see here is what happens. This value is A B complement, because here A B will provide to this particular NAND, that is A B complement. Again A B complement to make, that is a simple A B. Okay, so A B complement, again A B complement, here A B complement. Okay, then complement of A B actually, here complement A B, here A B into A B complement, whole complement, that is A B, you can tell as A B, because A B complement is A B complement, again complement, that is A B. Okay, so in this way we can design different logic gates using NAND gate. Okay, now we see different types of NAND gates. I will explain. You see, same thing, another similarly, OR gate we know. Okay, OR gate we know, still that is we define in this way. Here you see one is NAND gate, always use NAND gate. Here one NAND gate, here we define in this way. Okay, like here you see here A, here is B. Okay, so whenever go through here this particular A complement, actually here is A complement, I have already discussed this. This is A complement, here also B complement. Okay, here also B complement, very simple way. So now we see, again we just consider, that is again another NAND gate defined in this way. Okay, so now we see here is A complement, here is a B complement, again product of that. Okay, what you write here? Here A complement dot B complement. Here A complement, here is B complement. Again complement is there. Again complement is there. So if we go through this kind of a concept, then what happens? Here one that is a formula is there, the De Morgan's law. According to the De Morgan's law, the value will be, that is A complement complement plus B complement complement, like this. Okay, I will discuss that is how De Morgan's law will apply. That means, see, suppose any complement A plus B complement, A plus B whole complement, then that means A dot B complement, or A complement dot B complement whole complement is equal to A complement complement plus B complement complement. Okay, that is one rule is there, De Morgan's rule. So in this case what happens? A complement complement means A. Okay, A complement complement means A. Here similarly B complement complement means B. Okay, so now you see how it is designed, that is A plus B, that is OR gate. A plus B means OR gate. A plus B or OR gate defined on A and B inputs in this way. Okay, how it is designed? Based on NAND gate, we design OR gate in this way. Another concept also we can apply. Okay, so next is similarly another concept also we see how it is designed. This is the AND gate. All things designed through AND gate. Now see another way. Now we apply similarly using NOR gate. Okay, similarly we can write implementing of all gates using NOR gates. That means we have to create different gates values using NOR gates, just like a NAND gate. Okay, very simple. Again we also design. Similarly NOT gate, just like previous, but here what happens, always use NOR gate. Okay, very simple way. You see, NOR gate means just NOR symbol we just provide. This is the NOR symbol. Okay, and here you see, here is A value, two value just get it, A value and two value of A provide to the NOR gate. Then what are the result? What kind of result we get it? That means you see here A plus A. Okay, that means here A plus A, then AND, or no, that is a not complement of that. A plus A means A. Okay, A plus A means A, that is A complement. So not get A we define in this way, not get A means A complement. In this way we get define. Next, that is a OR gate. Okay, means a NOR gate NOR gate we define in this way. Very simple way. Same thing, NOR gate use. So since OR gate, so two values A and B value, we will provide A and B value. Okay, and A and B value, and also we can take this particular this value, what you will get here, you see, A and B value, A plus B complement. But whenever go through this particular value, what you write, A plus B complement, we get A plus B complement. Then you see a plus b complement, again what happens, if we go through this one, again we add another NOR gate, okay. So one part is here, similarly another part is here, okay. That means a plus b, what you write, a plus b complement, here also a plus b complement. What is the result? That means a plus b complement, again complement, because two part, here is a plus b complement, here is a plus b complement, then two times complement, okay. So what happens, go through that, then what is the result? That is a plus b, that is we can write a plus b, sorry, a plus b or a plus b, we can write a plus b, okay. In this way we can write also a plus b in this way. So this is the another concept of this OR gate, this is a plus b. Why? Because here you see a complement plus b one part, another is a complement plus another part, okay. If it is x, for example a plus b is x, okay, we can define in this way. Suppose a plus b is x, sorry, not complement, only x is a plus b, that means x complement means a plus b complement. Here whenever go through here, what happens, x complement plus x complement whole complement, that means x complement whole complement, okay. That means what you write, a plus b complement, again complement, x is a plus b complement, x complement is a plus b complement, again complement. What is the result? So result will be, that is a plus b, only a plus b, okay. So in this way we define that particular OR gate, okay. Next another point, another also gate we can use. Okay. So now you see another is a AND gate. AND gate, that means we have to create AND gate or one AND values using NOR gate, because it is continuing using NOR gate. So now very simple way, NOR gate is defined in this way, okay. One part is A and another part is A. Similarly another also, one part is B, another part also B, okay. That means whenever not coming here, what you write here, A complement, because A plus A, here complement, A complement. Similarly here is a B complement, okay. A complement and B complement is output from these logic gates. But here what happens, again NOR gate also we design according to our requirement, not a requirement, but always use NOR gate like this. Here another NOR gate. This NOR gate is considered as this input, two input, A complement and B complement. Again this NOR gate we can use. So what is the result? Very simple way. That means A complement here plus B complement, again complement, whole complement separately. You see, very simple. We separately we consider this complement. In this case what happens, very carefully you see, if A plus B whole complement, here we apply De Morgan's rule. De Morgan's rule also we apply here. Here what happens, since A plus B, the symbol, the operator will be changed that is a dot b, okay, a dot b result will be like this, a complement dot b complement. So total result will be a dot b, like this we can get it. Okay, very simple, because some that is concept is there. Whenever we go through any complement, we can get in this manner. Like this we can tell the De Moivre's law, a plus b complement is a complement dot b complement. This is the one rule is there. Okay, so if you define in this way, so instead of a, what you write, we wrote a complement, plus b, instead of b we wrote b complement. So just we apply this rule, a instead of a we write a complement, a complement again a complement, plus b again b complement, so a dot b. Okay, in this way we can get, that is a AND gate. Okay, AND gate we get, we can create AND gate and operations, but using what, that is a NOR gates. Using NOR gates we got this AND gate operation. Okay, so in this way different categories of concept we can consider for AND gate, NOT gate, NAND gate, NOR gate. Okay, different types of gates we can also consider. Okay, so this is the way to define, to design different gates whenever we consider either OR gate, NAND gate, or using NAND gate or using NOR gate. Also define OR gate, NAND gate, or any other gates. Okay, so different category of gates we can also design or define. Okay, next, now we will discuss regarding on some application of or properties of XOR gate. Some properties will define how different properties can be defined using different values. Okay, I will explain that part, but you have to see that how it is considered of a particular category of operations, that is whenever we will take different values of inputs. Okay, we will see, we will continue this particular through application of XOR gate in a different ways. Okay, so different applications of XOR gate we will consider, that is next lecture I will tell, because here what happens, some concept is there, we will apply different values of a, b, c value using the XOR gate. So I will explain in next lecture that application of or properties of XOR gate. Okay, so thanks to all to watch my videos. Today I explained this particular part, different logic gates and its algebraic function and a truth table, how it is designed, how it is defined in a different ways. Okay, so I hope all of you understand that part, and also that is a different logic, how it is designed, you also apply as your requirement. Okay, thanks to all, thanks to all stakeholders watching my videos. Thanks to all, and please subscribe my channel, and if you give any comments, please comment on different videos, and by which will improve our channel and also videos. Okay, thanks to all.